Hello everybody, welcome back. Here we are beginning chapter 9. And chapter 9 is all about the quadratic function and the ways that it can pop up. The first example that we're going to look at has to do with radicals and how we can solve equations with radicals. So here's a very simple example. Suppose we know that the square root of x minus 5 is equal to 4. Now the point here is that we want to get rid of the radical. And since we have an equation like this, all we need to do is square both sides. And when I do that, on the left, if you take a radical and square it, you get what's under the radical. And so therefore x is equal to 21. And there's our solution. That's pretty simple. One of the things to always beware of is, let me just write it down. Watch out for extraneous solutions when squaring. And what that means is, it's very possible that when you square and you go from the original equation down to this equation, that you may have something which is a solution to this equation, but not a solution to the original equation. And we'll look at a couple of examples in which that's the case. Okay, so here's a slightly more complicated problem. Here, instead of a square root, we have a cube root. And so what do you do to get rid of a cube root? Remember, a cube root really is the same as raising something to the 1/3. So if I raise it to the 3, that'll deal with it. And that gives me 2x plus 1 is equal to 27. Subtract 1, divide by 2, and you get x is equal to 13. If you check that, you put 13, 2 times 13 is 26, plus 1 is 27. The cube root of 27 is 3. Okay? So now let's look at one in which we get that extraneous solution popping up. Okay, so check this one out. And what do I do to get rid of the fourth root, which is really the 1/4 power? I raise each side to the 4th power. And that gives me 3x plus 6 is equal to minus 3 times minus 3 times minus 3 times minus 3. That's going to be 81. So subtract 6, divide by 3, and we get x is equal to 25. Okay, so now let's check. If you put 25 in for x, you're going to get 75. 3 times 25 is 75, plus 6 is 81, and the fourth root of 81 is equal to 3. And that's not equal to minus 3. So therefore, to this particular problem, there is no solution. Okay, so there's an example of having to go back and check and see what you get. And notice that they are not equal. Okay, so here's a problem that looks a little bit more complicated. There is a radical in it, but we don't want to square yet. So one of the big keys here is we want to isolate the radical. What that means is simply get the radical all by itself. So subtract x from both sides, and you get the square root of 4x plus 1 is equal to 5 minus x. And what you want to do now is square both sides. Okay, and then we're cooking. So if I do that, what I get is 4x plus 1 is equal to 5 minus x, quantity squared. And you should be able to get this when you do that. So there's a quadratic equation. We got to get everything over on one side. So we rewrite it as x squared minus 14x plus 24 is equal to 0. And now we want to factor that, and it factors like this: x minus 12, x minus 2 equals 0. So the solutions are x equals 2 and x equals 12. But now we absolutely must remember to check in the original equation. And if I put 2 in the original equation, I get 2 plus the square root of 9, and I'm asking myself, does that equal 5? And yes, it does. So x equals 2 is a solution. How about if x is 12? What I get then, if I put 12 into the original, and by original I mean the very first one, so now I'm going to let x equal 12, what I get is 12 plus the square root of 49, and does that equal 5? No, it doesn't. So therefore, 2 is a root, 12 is not, and so the only solution is x equals 2. So always, always, always very important to go back and check the solutions you get after you have squared to make sure that you don't have extraneous solutions. And in this case, we did have an extraneous solution. Okay, so here's another level of difficulty. What you notice is we have two radicals here. And the trick here, well, not the trick, but the strategy is that we need to separate the radicals. In other words, rewrite this problem like this. Square root of 6 minus 2x is equal to 3 plus the square root of 2x plus 3. And now what we have to do is square both sides. So this gets a little bit messy, and we've got to kind of stay with it, because when you square the left, let me just indicate that. So we're going to square both sides. And that's a binomial that we're squaring on the right, so we want to make sure we use FOIL. And so when we square both sides, here's what we get. We get 6 minus 2x is equal to 9 plus 6 times the square root of 2x plus 3 plus 2x plus 3. So that's what you get when you square a binomial. So what we do now we just have one radical, and so we isolate it and square. So when we isolate it, here's what we come down to. 6 times the square root of 2x plus 3, and you should check this work to make sure that I've done it correctly, is equal to minus 4x minus 6. And what we do then is we square both sides, and we get, finally, I'll do a lot of simplification here, and you should always check it. We get 16x squared minus 24x minus 72 is equal to 0. We can divide both sides by 8, and we come down to 2x squared minus 3x minus 9 is equal to 0. And the solutions here are x is equal to minus 3 halves and x is equal to 3. And you should believe that we need to check. We actually squared twice, right? So when I check, what you'll see is that this works and this doesn't work. And it's really important for you to go back and verify that minus 3 halves works in my original, but 3 doesn't work in the original. Okay, so there you go. And lots of interesting problems with radicals that give rise to quadratic equations. Okay, so make sure you do check through every step here, because I left a lot out, and ask questions the next day if you have them.